This is my third video on OMNeT++. So now we're going to be talking about the famous NED language, which is the network description language. Is a high-level language that is used to define a network structure and its components. So using the NED language, you can create and define simple modules, build compound modules out of the simple modules, and also build networks out of those compound modules. But before we go to all that, let's talk about what the simple module is. So, simple module is, for example, in this case, a handler. This is a simple module. So simple module is usually a single icon, and what it has in this case is, when it defined it, is defined as a simple handler. So this handler should be the same name as this one, but we'll go back and look at it more later. So in this case, this handler has a parameters. So if it has a parameters, it only has the display. So in this case, it's displaying it as a source, which means that it's using this icon, this particular icon. If I would like to change this icon, I could simply change it from here by just going to background source. I have a bunch of icons that I can change it to, but I'm using it as a source only. And there's another concept of gates in NED language. So when you have a simple module, you would have to define two things for sure. One is the parameters, which are here in this case only display, and gate, which is an input and an output gate. So there's another gate called in-out gates, and you can also make gates into arrays. So let's look at another simple module. So this simple module would also use the classifier, which is classifier icon. And by the way, look at the way I am using the source and design to go from the source code to the actual design, and the design to the source code. So here, this classifier also has two parameters, but what's different about this one is its input gate is an array and its output gate is an array as well, so it has more than one gate. And I'm not really specifying how many there are, so I can give it as many gates as I would like. Now, another simple module we have is a queue. So a queue in this case is a parameter, so it has a capacity in the parameter. So before now we're just looking at the display. So so queue is this color, this icon, but yet it has a capacity, which is an integer, and it's by default 1. So because this queue can only handle 1. And then we have two gates with an in and out gate, and that would be it. So this is the simple modules that we have in our project here. So a simple module is, by the way, simply the active component of your network or your model. So the OMNeT manual defines it as simple modules are the smallest building blocks for your module, and there are the active components of the module. So let's move on to the next thing, which is a compound module. A compound module, for example, here, this is a compound module. So a compound module would be, you have a computer, so this is the icon. So where do we define the icon? Here. So you can see this is a laptop, right? I chose it as a laptop. If I wanted it to be a different, for example, if I wanted it to be a computer, instead of that, I would choose a computer from here, which is this one, right? But we don't want that for now. So, and then we have the handler, which is our handler. So here, this code, this here, as a handler, and then the queue, which is the queue here. So our compound module is made up of two things, two simple modules, the handler and the queue. So we talked about gates, right? So in our gates, the simple modules had gates, And also, the compound modules also have gates. So how are compound modules different? So compound modules are made up of simple modules, but also they have their own characters. So what do they have? One is they have parameters, and they also have their own gates. So they have an in and out gate in this case. And they also have what we call a section called submodules, which means they're going to be defining as smaller modules, which in other case can be compound or simple module. In this case, you have a handle simple module and a queue simple module. And if you look at this, this is at this place. So this is the position of the simple modules. If you like, I can change the capacity here if I want capacity to 2, and this would be perfectly fine. Now that I have changed, I've modified this object, the queue object, to have capacity of 2. The other is the connection. So the computer compound module also have connections because you have modules and they need to be connected. So for example here, the handler out. So for example, let's start with the N. So in the design here, here's where you have the input gate, and from the input gate, it goes into the input of the handler, which handles the packets or the messages that come to it. And then here you have another out. So from your handler, it goes out into the queue. So it goes out into this queue, and then from that queue, it goes out through the out gate of the compound module or the main module. So we can add more things to this. For example, if I wanted to add more classifier here, all I have to do would be, I wouldn't have to code it. I could simply I would click here and I would click here. So now I have a classifier. It's not doing much. It's been defined, right? See, it adds the code for you. So the good thing about NET is that you don't have to know a lot. You just have to know your parameters and gates. And if you have the simple modules, all you gotta do is use the GUI designer to connect the larger modules with the simple modules. And you don't want that, so let's get rid of that for now. And then another compound module here is my hub switch. So our project is sample project is simple hub switch which receives message and sends it out to everybody. So and duplicates it and sends it out. So in our case here, this particular hub switch has one gate, and then it has a bunch of gates, but it also has an output gate and 4 queues. As you can see, it has 4 queues. I could have just simply brought them and dropped them here, but then it has these connections. For example, the classifier, the output of the classifier is connected to the input of the queue. But how do you connect it? So in this case, we've seen that the classifier has an array. So this array is not, we don't have to specify the index of the array. So NED lets us simply do plus plus and it would move to the next gate. So whenever I try to connect the next gate to this, the out plus the out, I would connect to the next gate. So in this case it's 0 and then it moves to 1, and it moves to 2, it moves to 3. And if I were to connect another thing to a gate here to the out, it would be connecting to the 5th one. Also, the queue out is connected to the output here, but then you can also use a for loop to connect gates. For example, here this is a pretty simple repetition because I'm connecting an array gate to another array gate. So and I have 4 of them, so I would simply do 0 to 3 and then connect this way, and that would simply connect it and have an output like this. Alright, so let's move on to another type of module, which is called a network. So the network is a combination or is built out of compound modules, and also sometimes simple modules as well. So networks start with the keyword network, while compound modules start with the keyword module. And the network doesn't have a gate or parameters. All it has is the submodules and the connections. So it can have parameters sometimes. Yeah, it can have parameters by the way, but it doesn't have its own gates because it's a network itself. It's not a component network. So in this case, I have a for loop that's connecting each computer to the hub switch, the input computer to the hub switch. So you can't really see that there are 4 computers here, but there's 4 computers and there are 4 connections in here. So we'll see that how it goes during simulation, but that's what we have here. So, if you see one thing, we have something called CH here. So in my case, I have defined my channel. I could have simply used the same thing I've used in the other connections such as this, but since this is an external connection, we would like to simulate a certain kind of latency and capacity. So in this case, your channel would have 1 gigabyte of the channel I have would have 1 gigabyte of speed, gigabits of speed, and 500 nanoseconds delay, which is the standard delay for 100 meters of fiber optics. So, as you can see, we have everything we need, and this is our NET language. So we'll see more about how the NET language was converted into simulation on the video that's going to come after the next one. But the next one is going to be how we're going to be writing the C++ code for such type of language.